welcome back, fellow design people. I just figured it out. I figured out how we're gonna fix all the problems on the Slippy Spheres, as I'm calling them right now. So that means welcome back to yet another RC with Adam design challenge, 1 hour design challenge. How do we get these things connected? Because the rules are that we need, the rules I just came up with in my head, we need to have each hemisphere move individually, independent of the other hemisphere that it is connected to, and then we need to be able to pinch both hemispheres together and still have this bar move freely. Do a center point rectangle, call it 5.5. Half a millimeter should be a good amount of tolerance. We might need to check that elephant foot compensation as well on that connector bar. The plan is to put indentations in this connector and then put little basically barbs, like little hook that it kind of springs into. 14, I think, because then that way we'll have a whole number's worth on each side. Whoa. Yeah, so we don't want it to be so big that it gonna break, but that's probably reasonable. Okay. Let's just make this a little bit bigger. Then we're gonna mirror the little that guy right over there. Just revolve that guy. Yeah. All right. So let me bring back my parts. We don't want to have those guys that far out because that was like the whole point. All right. Look at that. Look at that nice little shape right there. Let's go back over here. Let's do a chamfer. That looks pretty good. That looks better though, actually. And you know what else I could do? I could literally print 2 of these in half and then slide them together and they get locked in place. You put it on both sides. That looks decent. Now, here's the idea. The next thing that we want to do is we're basically going to do a negative version of this pin right here. So let me take this sketch. Yeah, the very same sketch. We're going to take the middle connector bar out of there, and then we're going to create an offset. There we go, an offset. So offset that, offset that, offset that. Let's make it 2 millimeters. Let's just call this guy 3. All right, it's time to Boolean, which is a fun thing to say. And then we're like, yeah, we want to offset all. Okay, let's put that back. There we go. So we actually don't want them to be too big because they'll be on both sides. So 0.2 should be sufficient. All right, so that's 0.2. Let's keep tools for now and say, okay, now get rid of that connector bar, or get rid of that pin, my bad. So let's just imagine that we took this guy right up here. Let's just mirror that guy. Across from that, great. Now we have our line, because we're gonna need an actual line to basically dissect this, because we're looking at this 1/2 here. Take a line straight up. Ah, geez, I'm just gonna really eyeball this because we don't want to do that, because this is gonna be flat. Then actually we could just like chop it off like that. Okay. Oh man, this went way differently in my head. I'll tell you that right now. It needs to be a full line. Let's just imagine it here. So revolve axis right there. So we revolve this. It's a negative, so it's remove it. Okay, so that's the idea. From right here, and then do like a nice little curve. So something like that. Yes. That's kind of like what it should be like. So, all right, so this collar is really thick. Very, very thick. Probably won't bend like at all, because it really probably needs to be pretty darn thin to be able to bend. And so this way it's all contained inside of the sphere or the hemisphere. Then we place cuts into here. Cool. And then on that face, and then what we're going to do is we're going to use these lines. We're going to say use, and we're going to use that one, use. Let's just call it 9. so that it's a nice even number. So center point rectangle, and then basically we need to put a cut in here, but the question is how big of a cut do we need? What, 0.5, 0.8? Would they be a millimeter? I mean, they don't really need to be much. Okay. I guess I really didn't need to do another circle. So let's get rid of that. And then we'll just do another one here, and we'll say 9. And then that's 0.8. Let's extrude, 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 extrude. Great. And let's bring back part 1. Nice. I think let's give that a try. Let's give that a try. Oh, we're over an hour just in designing this. Oh my gosh. Editor, I'm so sorry that you had to go through this. Let's look at the section view. Section view. 90. There we go. And looking at this 90 degrees, it's not quite center, but it is 90 degrees, and that's kind of cool, actually. So we can see how that is. So I'm feeling like we need to do some other kind of, we need like another relief cut right here. Get rid of it. Let's give it a try. So make sure that the tolerances are correct. Let's do 19. So let's say okay, and then look at that. So then we have tons of room. There we go. This is going to be the most exciting version of the Slippy Sphere. I don't know, hemisphere with barbs. This one is the pin. Is the connector bar. Connector bar. Great. Export this. We're just going to call it that for right now. So fine millimeter. It is. Export. All right. Cool. Okay. We are going to we're going to put it in Bamboo Studio. So here we go. So this used to be called the 2-sphere. All right. So I'm going to drag and drop these guys in here. Let's see, those 4 and then this guy. So those are our old ones. Get them out of here. So if we set the z-axis to 0, apparently it will just print halfway. But I feel like if we do that, then there's going to be a weird seam, and it's going to be like even worse. So let's just print it so that it's like not quite halfway. Let's give that a try. And then let's just slice this thing and see what it looks like. Oh, I did forget to change the geometry of the pin, but whatever. So strength. We really don't need grid. I'd rather do rectilinear to give us some more space there. But that's pretty much gonna do it. Come on, top surface, 200 on the top surfaces. It's fine. Print it. Print. It's printing. Woo! Bye. Alrighty then, here are the parts off the build plate. I stopped the print a little bit early because I realized that it would actually be helpful to see inside of these spheres to see what the what the pins are doing and all that stuff. That's what we got on that guy. Here's our pin. And then we have the 2 half pins. Anywho, and then we have our connector piece right here. In any case, first test, will the pin go through here? And yeah, it does. It goes through quite nicely. But in any case, here's what we came for. All right, this is why we're here. So will this fit into here? It is going. It's moving. What if we took the 2 halves? If this doesn't just fall apart. That is, oh yeah, we broke a pin. This one right here. All right, so there we go. Lesson here is we could just put more cuts in here, so we would just have a whole bunch of cuts. The second option would just be to basically allow these to bend more. The third option would be basically just don't make the head of the pin so dang wide. Or oh boy. Oh, so I've just pushed the pins through here. Okay, that's definitely not what I wanted. So, oh wow. My goodness gracious. Oh my goodness. Woo! That's crazy. A lot of that play won't even be in there once we thicken the connector bar. But that's a pretty easy fix. Making the head of the pin a little bit slimmer. That's going to do it for this design challenge. We're going to get back on this later though, because I'm not done with this. I'm not giving up on this until it comes to fruition. So thanks for joining me. Get out there, design something, print something. Have a fantastic day. And I'll see you again very soon.